Welcome you all students. Let's move to the next unit, Unit 3, Projections of Solids. Okay. In the previous unit, we learned about the projections of point, projections of straight line and projections of plane surface. What do you mean by point? Point in the sense, it's a dimension-less object, right? And straight line, it's a one-dimension object, it has a length. And what about the plane surface? Plane surface is a two-dimension object, it has a length as well breadth, okay? It's a solid is a 3D object. Solid is a 3D object. So here we are going to deal with the three-dimension object. It has length, breadth and height. So for example, so this is the object, three-dimensional object. See, it has the length, breadth and height. Such object we are going to deal here, and we are going to learn how to get the projections of those solid stuffs, right? So let me move to the classification of solids. The solid is classified into three. One is a polyhedra, solids of revolution, and next last one is a frustums and truncated solids. Okay, polyhedra is again further classified into regular polyhedra, prism and pyramid. Okay, so regular polyhedra, prism and pyramid. So the regular polyhedra is again classifying into 5, which is cube, tetrahedra, octahedra, then dodecahedra and isosahedra. Okay, isosahedra. This regular polyhedron in the sense, the polyhedron shows the face with similar size and shapes. Such polyhedra we call it as a regular polyhedra. So here the cube, first cube, this is the cube object. Cube in the sense, all the 6 faces, see 1, 2, 3, 4, 5 and 6. All the 6 faces with what? Perfect square. It has a 6 square faces. Such object we call it as a cube. Okay. So other name for the cube is a hexahedron. Hexahedron is in 6. It meaning 6 what? Perfect square. Right. So as far as this cube concerned, these are the edges or these are the sides. We call it as sides or edges, and these are the corners, and these are the square faces. These all the things are square faces. It has 6 faces. Okay. So then tetrahedron, tetra in the sense, we know it's a 4. So you see this object we call it as a tetrahedron. Okay. So here if you see, it has 4 faces, and 4 faces are with what? Equilateral triangle. Equilateral triangle. See, 1, 2, 3, 4. 4 faces we have. All the 4 faces, it's an equilateral triangle, right? So these portions we call it as corners, and these are the portion we call it as edge or sides. Okay, or slant edges. In the accurate manner we can call this as slant edges. Fine. These are the triangular faces or lateral faces. Okay, fine. So as far as our study concerned, cube and tetrahedron will be our part. This octahedron, dodecahedron and isosahedrons are not covering up in the syllabus. Octahedron in the sense, 8. So it has 8 equilateral triangle in the polygon. If the polyhedron has 8 equilateral triangle, then we call it as octahedron. Dodecahedron in the sense 12. It means 12. It has 12 pentagonal face. It has 12 pentagonal face. So if the polyhedron have the 12 pentagonal face, we call it as dodecahedron. Isosahedron in the sense, isosahedron, it consists of 20 equilateral triangle. So if your polyhedron has the 20 equilateral triangle, we call it as isohedron. Okay, fine. Next, prism. Prism in the sense, if the polyhedron has top base and bottom base, we call it as a prism. Okay, so as far as the prism concerned, based upon the shape of the top base and bottom base, it is divided into 5. It is divided into 5. One is triangular prism. Next one is a square prism, and next rectangular prism, and next pentagonal prism, and the last one is a hexagonal prism. Okay, so for your observation, I have an object. See, this is a top base and this is a bottom base. So if the object has top base and bottom base, it's nothing but a prism. Okay, so based upon the shape of the base or face of top and bottom, we call it as we will be specifying the name as a square prism or pentagonal prism or a hexagonal prism. See here, what is the shape? It's a square. So we can call this object as a square prism. Okay, I hope you are understanding. Okay, so this portion we call it as top base or bottom base, or we can also name as a top face or bottom face. As well, this portion we can call it as top end and bottom end. So by three name we can name the things. Okay, base or ends or face, right? So and see, the top base and bottom base are connecting by the lateral faces, which is a rectangular face. This portion we call it as a rectangular face. Rectangular face, or else also it can be named as a lateral face, or also we can call it as a parallel faces. Okay, and this region, see, this region we name as longer edges. This region we call it as a longer edges. As well we can name as a parallel edges. Okay, as well we can name as a lateral edge, longer edge, parallel edge. And see, in the base side, either in the top or in the bottom, we have as well the edges. So we call it as a base edge or we call it as a base edges. These are the base edges. Say here as well, and these are the corners. Okay, fine. And next we shall know about the hexagonal prism. So this is the hexagonal prisms. How will you identify this as a hexagonal prism? Yes, by the true shape at the top or bottom base, right? So here if you see, you can see the pentagonal prism, right? Pentagonal prism. So this is the top base and this is the bottom base. The same terminology which I named in the square prism, it follows for the pentagonal prism as well. These are the rectangular faces, the top base, bottom base, right? These are the corners, these are the edges of the base, and these are the longer edges. Okay, and one more thing I have for your observation, which is a hexagonal prism. See, the top base and bottom base, it's showing you the hexagonal shape. So it's a hexagonal prism. Okay, top base, bottom base, longer edges, and rectangular faces. As far as this prism concerns, it has two bases, okay, or two faces or two ends, and it has the rectangular faces. Okay, it has the rectangular faces, right? Next, move to the pyramid. So pyramid concern, it as well has 5 pyramids based on the true shape. Okay, pyramid in the sense it has one base. It has a one base and it has apex. I will show you. So first of all, based on the true shape at the base, it is divided into 5. One is a triangular pyramid. Triangular pyramid. And the second one is a square pyramid. Square pyramid. Then rectangular pyramid. Rectangular pyramid, and then pentagonal pyramid. Pentagonal pyramid, and then hexagonal pyramid. Hexagonal pyramid. So here, guess what is the object? The base is a square, so it's a square pyramid. Okay. So this pyramid concern, it has one base and apex, and here you can see the faces, which is triangular. It's an isosceles triangle. These are the faces or isosceles triangle. From the base, the isosceles triangles are meeting at a point. This we call it as apex or vertex. So three main parts here. One is a base and vertex or apex, and the triangular faces, which is isosceles triangle. Okay, fine. So as far as this object concerned, that means pyramid concerned, this one we call it as base, and these are the edges, we call it as a slant edge. There in the prism we call it as a longer edge. Here we call it as a slant edge. These are the triangular faces. This is the apex or vertex. Okay, and this portion, since it is the edge in the base, we call it as base edges. Okay, these are the corners. Fine. And next, what is the object? 1, 2, 3, 4, 5, 6. 6 sides are there, right? So it's a hexagonal pyramid. Okay, the same terms we will be giving for the hexagonal prism as well. So this is the base, this is the apex or vertex, these are the isosceles triangle. Okay, these are the slant edges. And one more thing I have. What is the object? It's a pentagon. Okay, 5 sides. We have 5 sides at the base, so we can say it's a pentagon. Okay, base, apex or vertex, triangular faces, and slant edges. These are the base edges, and these are the corners. Okay, I hope you got the idea about the object of pyramid. Let me move to the solids of revolution. Solids of revolution. We call the object as solids of revolution because the object are generated by revolving the plane surface about one of the edges. Okay, so based on the thing, it is classified into 3. One is a cylinder, and second one is a right circular cone, and third one it's a sphere. Okay, cylinder, as far as the cylinder is concerned, take the plane surface of rectangle. It's a rectangular plane surface, right? So take the plane surface of rectangle and fix one of the edge and try to revolve it. Something like this. Try to revolve it for a 360 degree. For one complete revolution, you try to revolve it, and you can see the formation of the cylinder. You can see the formation of a cylinder. When you are revolving with respect to this side, the area covered will be producing or generating the object called the cylinder. This object. Okay, this is the cylinder. So as far as the cylinder concerns, top base, bottom base, and here there is no slant edges or parallel edges or longer edges. The area bounded, we call it as generators. There is no edges, only the surface, we call it as generators. Okay, and then cone is formed by revolving the right angle triangle, revolved by the right angle triangle. Here as well, we are going to revolve about one of the edge. I am going to fix this particular edge and try to revolve it, something like this. Fixing it, just revolve it, and the area covered will be generating the object called the cone, something like this. Something like this. If you are revolving with respect to this edge, you will get the object called what? See, right circular cone. So here in the cone, we have one base, and this point we call it as apex or vertex, just like pyramid. So cylinder concern, it has two bases, top base, bottom base, or top face or bottom face. So here it has only one base or only one face, and this region we named as generators. There is no edges. Okay, keep it in your mind. The cylinder or cone concern, there is no edges. Okay, these are the generators. And the last one is a sphere. Sphere concern, it is obtained by revolving the semicircle, and we fix one of the edge. This edge, try to revolve it, something like this. If your observation is right, we will get the object like this manner. This will be the formation of what? This sphere. When you are revolving with respect to one of the edge, we get the sphere shape, right? Fine, I hope you understood how we are generating from the right angle triangle the cone, and from the rectangle how we are generating the cylinder, and for the sphere how we are generating the sphere. So the next one, frustum and truncated solid. Just take the frustum. For example, in order to get the idea of frustum, I am going to take the cone, right circular cone. If the cutting plane, so this is a cone. If the cutting plane is just cutting the object just parallel to the base, just parallel to this base. If the cutting plane is influencing the object just parallel to the base, something like this, then the removed object, this particular top object is removed, and the remaining portion will be something like this. After cutting, the top portion is removed, and the remaining portion will be showing the observation something like this. This object we call it as a frustum. That means if the cutting plane influences the object parallel to the base, the produced object will be a frustum. This can be possible for all the pyramids, triangular, square, rectangular, pentagonal, hexagonal pyramid. As well, it is possible for the prism, triangular, square, rectangular prism, pentagonal prism, and hexagonal prism as well. Okay, and then we can move to the truncated solid. So for the same as well, I am going to take the example, the right circular cone. Okay, so here I am going to cut the object with the help of the cutting plane, just inclining with respect to the base. Okay, there I cut the object just parallel to the base, but here I am going to cut or influence the object with just inclining with respect to what? The base. Just like this. I am going to take the object. With respect to base, it is inclined somewhat. When you are influencing in such manner, if you remove the top portions, the remaining portion the remained portion will be something like this, okay, something like this. This kind of object we call it as truncated solid, okay. So here the cutting plane influencing the object inclined to the base. Here it is parallel to the base. That is important. Frustum in the sense cutting plane is parallel to the base. If it is a truncated solid, the cutting plane is inclined to the base. Okay, these are as well possible for all the solids of prism, pyramid, the regular polyhedra, as well the solids of revolutions. Okay, so I hope you got the things about the classification and the terms involved in the object. Okay, next we shall move to the positions of solids. The same positions we have also learned in the where points, straight line, as well in the plane surface. Okay, the same manner we are also having the positions of solid. Now we shall just see the look. Okay, positions. So first position concern the axis is perpendicular to HP and parallel to VP. The second position is axis is perpendicular to VP and parallel to HP. And the third position, axis of the solid is parallel to both HP and VP. The fourth position is axis inclined to HP and parallel to VP. Fifth position, axis inclined to VP and parallel to HP. And the sixth position, the axis is inclined to both the planes, both the HP and VP. Okay, so these are the 6 positions, right? So here in the solid we are specifying the object with the help of the axis. So we must know the idea about the axis. For example, if I take the prism, this is a hexagonal prism. Okay, so I can give the statement as for the axis, if an imaginary line join the top base, center of the top base and bottom base, which is called as a axis. The line, an imaginary line joining the center of the top base and the bottom base. That means the axis will be something like this. Okay, imaginary line passing through the top base and center of the top base and the center of the bottom base. So with the help of this, we are going to specify the object. The axis is parallel to HP, axis is perpendicular to HP, or axis is inclined to the HP or vertical planes, something like this. Okay, so remember it, axis in the sense it's an imaginary line passing through the center of the top base and the bottom base. Okay, so let me concentrate now on the first position. Axis is perpendicular to HP and parallel to VP. Okay, for that I gonna take the object which is a square prism. Okay, square prism. So now just imagine this is the horizontal plane, this ground is a horizontal plane and this board is a vertical plane. How to keep the objects? So see, the imaginary line passing through the top and bottom is an axis which is something like this. Okay, so with the help of it we have to position it. Axis is perpendicular to HP. If I keep the object like this, what is the position? See, now the axis is making perpendicular with what HP and just parallel with VP. So this is the exact position for the first condition. Okay, so always remember, if you are doing the projection works, if the true shape, that means always we have to start with the true shapes, right? So just see, in the front view or in the top view, we can see the true shape. In which view we can see the true shape? Either in the front view or in the top view. Yes, from the top view we can see the true shape. Am I right? True shape in the sense, if it is a square prism, square is a true shape. If it is a hexagonal prism, the hexagon is a true shape. So here from the top view we could able to see the true shape. So that must be drawn first, and in the front view we can see the height of the object. That means rectangular face. Okay. So the same in the first angle projection we are going to take the projection. So take HY line, above the HY line it's a VP and below the HY line is a HP. When you are looking from the top, the projection will be falling on HP. We are well familiar. Top view fall on the HP plane. So in the top view, I am going to draw the square. Okay, take the square with a side 30 mm and height of the square prism as 60 mm, or we can take 65 mm. Okay, so first go for a line. It's a square, so you have to draw a what? Perpendicular line to the baseline, and afterwards with the help of measurement, if you do the cuttings, you will get the square. So in the top view, the square is observed. Okay. So naming, as far as the naming concern, I am going to give this as A, this is B, this is C, and this is D. And the bottom base concern, I am going to give this as P, Q, R, and this is S. Okay. From the top view, the top base is visible. This top base is visible. The bottom base will be invisible from the top. So A, B, C, D will be visible one. So I am going to give this as A, B, C, and D as a visible one. What happens to P, Q, or S? It's invisible from the top, right? So what we have to do? We have to name the things, but you have to name it inside the bracket. This P is just lying behind A, then Q is just lying behind B, and this R is just lying behind C, and this S is just lying behind D. So nearby A I am going to take P, and nearby B I am going to take Q, here I am going to take R, here I am going to take S. Next, what is the next step? The front view. So as far as the front view concerned, from the top view we have to take the projector lines. So perpendicular line, I have taken it. And we know the height of the prism, this prism as 65. So what I am going to do is, I am going to cut from this end, and I am going to form the boundary for the object. So this is the rectangular face. When you are taking the projector from each and every points or every from the corners, and if you extend it and if you take the height 65, naturally you will form the rectangular face. So this is the view which we can take from the front. So go for a dark line. In the boundary you can go for a dark line, and next the important work is a naming. Okay, so name concern, A, B will be a visible one, right? From the front, A, B will be a visible one, P and Q will be an invisible one. Top base A, B, bottom base P and Q. So here in the diagram, in order to mark the front view, you can look the object from here. The top A and B is visible. In the top A and B is visible. It's a front view, A dash and B dash. D and C will be invisible in the top. So D and C is invisible in the top. P and Q is visible in the bottom. P and Q will be invisible. P and Q will be visible in the bottom, P and Q will be visible and R and S will be invisible. So R and S is invisible. I am taken inside the bracket near the P and Q. Okay. So this is the front view and this is the top view. Next, we shall move to the second case. Axis is perpendicular to VP and parallel to HP. The second case, for the same I am going to take the square prism. For the same I am going to take the square prism with the same measurement of base side 30 mm and height of the prism as 65 mm. 65 mm. So here I am getting ready with the first angle projection. Above the XY line VP and below the reference line is a HP. As far as this position, second position concerns, it is perpendicular to VP. So axis, imaginary line passing from the top to bottom, axis is just perpendicular to VP. So the object should be kept something like this. Now see, the axis is making 90-degree width where VP plane, and for the ground, for the HP plane, it is making parallel. Axis is making parallel. So this is the HZ position for the second case. So if it is the second case, in which view we can see the true shape? Yes, right. From the front view we can see the true shape, perfect square, and from the top view we can see the height of the object. That means rectangular face can be seen from the top view. Okay. So always from the true shape we have to begin the object. So in the front view I am going to draw the square with the size 30 mm. It's a perfect square, so we have to make all the side as 30, something like this. Okay. As far as the name concerned, I am going to take this as A, B, C and D. This is P, Q, R and this is S. So this is A, B, C and D, because from the front view A, B, C, D will be visible. What happens to P, Q, R, S? It's an invisible line, invisible plane, right? Just lying behind the top base. Okay. So I am going to take P, Q, R and S inside the bracket. These all the things are front view, so it should be a dash mark. A dash, B dash, C dash and D dash. As well for the bottom base we have to capture with dash marks. Okay. And next, the top view. Top view. What can be seen? The rectangular face, right? So for which what we have to do? Just take the projector. From each and every corners, take the projectors like this. We know the height of the object, which is 65, So from the end cut with the 65 and close the boundary. This is the observation we can get from the top. So go for the dark line. Go for the dark line like this. So this is the view from the top. What about the name? What about the name? From the top, I can say I have taken this as A, B, C and D. I have taken this as P, Q, R and S. So I can say D and C will be visible here. S and R will be visible. Can you get it? What? This D and C will be visible and S and R will be visible. As far as marking in the paper, we can get the look such manner. This is clear. D and C is visible. S and R is invisible. Sorry, S and R is visible. What is invisible? A, B and PQ is invisible. In the top base, D and C is visible. So in the top base, D and C is visible. And in the top base, A and B is invisible. So in the top base, A and B I am going to take inside the bracket. This is important. First I am completing the top base. Okay. And go to the bottom base. In the bottom base, when you are looking from the top, S and R is a visible one. S or visible. S or is a visible. What is invisible? P and Q. So P is just behind S and Q is just behind R. So nearby S I am going to write the P and nearby R I am going to take Q. right? So this is the top view and this is the front view. So this is the projection of front view and top view for the second position. Let me move to the third one. Here the axis is parallel to both HP and VP. Let's see how the things gonna happen. Okay, the axis is parallel to both HP and VP. So third position. So as far as here, the third position as well, we're going to take the things in the first quadrant. So as far as the first angle projection, above the HY, VP and below the reference line, it's a HP. Okay. Think about the position. Just see, just imagine this board as a vertical plane and this ground as a horizontal plane. How we have to keep the objects? So this is the axis. This is the axis. Just passing through the top base and bottom base, center of the top base and bottom base. This is the axis. So how we need to keep for parallel to both HP and VP. When it is perpendicular to HP, I kept the object like this. When the object is perpendicular to VP, I kept the object like this. Now it is parallel to both HP and VP. See how it is. How it is. The axis now it is making parallel to HP and as well see it is making parallel to VP. So in such a position, it is satisfying the third position. So this is the exact position for the third case. Okay. So if it is the case, in which view we can see the true shape of the object. True shape in the sense it is a square prism. In which view we can see the square? From the front view or from the top view? Guess it. Here in the front view we can see the rectangular face. Look at from the top, which is visible. Say the same rectangular face is visible. So in which view we can see the rectangular, the square true shape? In the side view, either from the left side view or either from the right side view. So in such condition, always when you are going through the projection, if you know the true shape, we can obtain the final front view and final top view. So here in the left side view and the right side view, we can see the true shape. So what we have to do is in the projection work, we need to start from the side views. Okay, not from the top or bottom, from the side view. Since the side view is showing the true shape, we have to start from the side view. Okay, so I'm going to take the right side view. So we know right side view should be taken in the left. The left as far as the first angle projection concerned, we land in the orthographic projection. I'm going to take the side view, right side view. Okay, in the right side view, I have taken the square. Okay, so A, B, C and D is a visible. A, B, I'm going to give this phase as A, B, C and D. This phase is P, Q, R and S. Right. So A, B, C and D. Okay, the bottom base I am going to name as P, Q, R and S. Just like this. Okay. Now take the line to get the front view. So I am going to draw the front view. So I am going to take the horizontal projectors. This is a projector line, something like this. We are familiar, it is with the height 65 mm. So first I am going to take the vertical line in between the projector in order to identify the shape. Okay, it's a rectangular face, we know from the observation. So first I have taken the line and next by measuring 65, I am going to close the boundary. So this is the view which we can take from the the front view. So go for the dark line. The rectangular face is the visible one. How will you name it? As far as the side view is concerned, we have to look the object from the side. So what about the top base? A, D is a visible. A dash and D dash is a visible. In the top base, B and C is invisible. B and C is invisible. What happens to the bottom base? PS is visible. P and S is visible. And Q and R is invisible from this side. Q and R is invisible. Right? So next we need to draw the top view. So we know from the top view as well, it's a rectangular face. But how to obtain it? In the orthographic we learned, right? Now to get the top view from the side view, what we do is just we'll be drawing a 45-degree inclined line, something like this. Okay. So in order to get the trace, get the projector and intersect with the 45-degree inclined line and take it to the horizontal line, something like this. Now from the front view, take the projectors. So naturally we'll get the boundary without having any measurements. If your side view and front view is there, by going through the procedure, you will get the shape of the object, which we can observe from the top. Okay, fine. So now the naming is very important. Now it's a top view. So you have to look the object from the top. So here in the bottom base, S and R is visible and D and C is visible. From the top, S and R is visible and D and C and D is a visible one, right? So how we have to mark it? First concentrate on the top base. So D and C, right? So D, here we have to mark D, and C, here it is. Fine. And what about the top base A and B? A and B, from the top it is invisible, right? A here comes nearby D and B it comes nearby C. What about the bottom base? S and R is visible. S, here comes the S, okay, and R, it comes here. What about P and Q? It's invisible from the top. So P, so nearby S we have to take the P, and nearby Q we have to take the, nearby R we have to take the Q. So this is the front view, this is the right side view, and this is the top view. Okay. I hope you understood the third portion. Okay, how to work with it. Since the true shape is obtained on the side, have taken the work from the side view. Okay. Okay, we have taken the things from the side view and we got the front view and the top view. Okay. So important thing is in the front view marked as a dash mark, right? A, B, C, D and P, Q, R as the base points as a dash mark. And in the top view, we just write A, B, C, D and just P, Q, R S T without any dash mark. As far as the side view concerns, we have to remember it should be a double dash. Okay, side view concern, it should be a double dash. A double dash, B double dash, C double dash, D double dash. As well the bottom base, P double dash, Q double dash, R double dash and S double dash. You should remember it. Side view concern, it's a double dash, and front view concern, it's a dash, just a dash. Here the top view concern, it's just a without any dash marks. Okay, I hope you understood. Let me move to the fourth condition, which is axis inclined to HP and parallel to VP. Axis inclined to HP and parallel to VP. As far as the fourth and fifth condition concern, we shall know detailed manner while we are solving the problems. And as far as the sixth position, axis inclined to both HP and VP, it's not included in our syllabus. Okay, so just we are leaving it. Okay, so fourth and fifth condition we're going to see lot of problems based on it. Okay, so you will get a good idea. Okay, but I will give the introduction. Just axis inclined to HP and parallel to VP. Axis is inclined to HP and parallel to VP. This is the axis. Okay, this is the axis. When it is perpendicular to HP, I kept the object like this. When it is perpendicular to VP, I kept the object like this. Now it is making inclination with horizontal plane. So now see, it is making inclination with horizontal plane. So this is the exact position for the fourth one. Inclined to HP, making parallel with VP. So this is the case. Okay. So we know either from the front, either from the top, or either from the side view, we cannot get the true shape. From the top we can get it, but it will be a skewed one. It will be a skewed one, not the exact true shape and true size. So what we have to do is, in a single step, it is not possible to identify the views of front and top. So we have to go through the two stages. Okay, we have to go through the two stages for the fourth case concerned. So what is the step? I will teach you now. XY, it's a reference line above VP and below the reference line is a HP as per the first angle projection. So first stage, what we have to take is simple position. Simple position. In the second stage, we have to show the axis inclination. Axis inclination. Okay. So what we have to do is, in the simple position, if the axis is inclined to HP, we have to consider it is just perpendicular to HP. We are taking the assumption just like a plane. Okay. In the first position, based upon the axis, we are going to take the assumption, since it is inclined to HP, we are going to take perpendicular to HP. Inclined to HP in the sense, we are going to keep perpendicular to HP. So from the top we can see the true shape, and from the front we can see the rectangular shape of the objects, right? So if it is inclined to HP, we have to take the assumption, that means perpendicular to axis perpendicular to HP. Okay. For the fifth case, the same, it also inclined to VP. So we know it's not possible to obtain it, right? Here as well we have to undergo two stages: simple position, and we have to, the second stage we have to show the axis inclination. Okay. So here in the fifth position concern, it is inclined to VP. If I keep the object like this, it is making, the axis is making just perpendicular to VP plane and parallel to horizontal plane. Am I right? So the object is like this. Okay. If it is inclined, if I tilt the object like this, it will be making the position fifth. Now see, it is making inclination with VP and parallel to HP. So here as well the same situation, right? Just like 4. Either from the top or from the front view we cannot see the true shape. Either from the side views as well we cannot see. So what we will be doing is undergoing two stages: simple position and axis inclinations. In the simple position, we will be taking the assumption based on the axis inclination. Okay, here the axis is inclined to VP, so we are going to take the assumption as axis perpendicular to VP. Since it is making inclination with HP, we are going to take assumption perpendicular to VP, just like this. And we will be getting the things, that means true shape from the front view, and from the top view we can get the parallel phases. So by this we can get the final front view and final top view in the second stage. Okay. And one thing you have to clear when comparing with the plane, line and the solid, there is a huge difference are there. In the plane and line, we used to position the object just by the object. That means the straight line is inclined, the line is kept perpendicular, something like this. In the plane, we will be telling the plane is inclined to HP, the plane is inclined to VP. But in the solid, just with the help of axis, we are representing the position. So what is the difference is, in the plane and line, if the object, that means line or plane, parallel to any of the plane, in that particular plane, the true shape or true object will be seen. Okay, in the plane, whenever the object, the plane as well the line, whenever the object is kept parallel to any of the reference plane, okay, in that particular plane, we'll be getting the true shape and true size of the object. But here, since we are defining with the help of axis, okay, the true shape of the object can be seen when it is kept perpendicular to any of the plane. It is important point here in this solid only. When the object is kept, that means when the object is kept perpendicular to the any of the plane, in that particular plane we can see the true shape. Okay, and the important thing in the fourth and fifth as well in the sixth, if you want to get the final front view and final top view, we will be carrying out with the 2 stage, and here we will be carrying out with the 6th stage, but it is not in our syllabus. Okay, so the method concerned we will be calling as change in position method. For the 3 and 4 we will be calling as change in position method. If the question is asked which method is carried out to take the observation of front view and final top view for the axis inclined to HP and the axis inclined to VP, or axis is inclined to both HP and VP, you should be aware it is nothing but change in position method. The following procedure is based on the change in position method, or change rotating object method, or we can also say change or rotating object method. Okay, we are following this to 4, 5 and 6 position. Okay, I hope you understood the things. Okay, in coming videos I will be posting the problems based on 4 and 5 conditions. Okay, at that time you will be getting familiar and you will be getting the better understanding regarding the projections of solid.